Hello everyone, myself Dr. Sonam Gupta, working as a professor in Akgec Engineering College in the Department of Computer Science and Engineering. So today we are going to discuss about document type definitions. Document type definitions which are an important part in the XML. So what is document type definition? What is DTD? So XML, as we all know, it is very flexible. We can use it anywhere and everywhere we want to use it. So the most programming languages that not only process a subset of all the possible XML applications. So what is DTD? DTD is document type definition which is used to establish the vocabulary for one XML applications. Like in the database we are having schemas, we can think of DTD more or less like it. It is a valid with respect to DTD if it conforms to the rules of the specified things, and most XML parsers, they can be configured to validate the data. If I want to validate my data, that the data description is there, elements are there, attributes must be having one value or two value, what value the attributes can contain, all these things the validation can be done in the DTD. This is the example of the DTD elements. Like if I want to write DTD and I want to describe the element, what is the syntax for it? I have to write it as like this, exclamation element, and after that the name of the element will be there. Like here, the name of the element is article. Now what the tag article will contain? Element is what? It is a simple tag. What it will contain? It will contain three things: title, author and text. So from here I can easily say that I have an article. In this article there are three sub elements: title, author and text. After that we will again define that what title will contain. So for that we will again write element title. Here what we have defined in title, hashtag PC data. PC data, as we know, which is parsed character data. Anything which will written over here, it will go through the parsing. Similarly for author, hashtag PC data. For the text, further we have defined three things, which is abstract, section star and the literature question mark. So that means these must be the elements which are over there. In the abstract, PC data will be there. In the section part, either PC data will be there or the index will be there, or many more things will be there. In literature part, we will be having the PC data, that is the parsed character data, and in the index part, which was written in the section, their data will be of the parsed character data. Here if I want that any element can have the character data, we simply just have to write hash C data. From here the C data, that is the character data, will be written. So content of the title element, that means it is the parsed character data. It is the title elements, that means that these must be followed by the title article tag, and after that all these three tags will be coming over there. Now this is section, this is the content, and it can contain 0 or more selections, as we know that star means 0 or more thing. Let's see the element declarations in the DTD now. So what is that thing? Element name and the content specification. So content specification can be any of these things, like it can be hashtag PC data, it can be any child, that is one child element. If I want to write the sequence of the childs, simply write by separating it with the comma. If I want one of the elements of either of these childs, so what we do, C1, pipe sign, C2, pipe 3, C3, so it will contain any one entry of that particular element. If I want possible number of counts, I want to write. If I write just C, that means exactly one such element will be there. If I add plus, that means one or more element will be there. If I write star, that means 0 or more, that means I can write the data or I can skip the data as well. Question mark, that means either 0 or 1, we cannot have more than one. So all these special symbols, they are used to define the structure count. So we can have these combinations as well to define the data. Now if I want mixed content, so for the mixed content what can I write? Text, PC data, index, site, glossary. So that means I can have any of the information for it. So similarly was the cases with this value. Like if I have written over here star, star what means 0 or 1, either I can skip all the values or I can just add one value to it. For the empty content, simply write empty. If I write over here empty, that will mark that the element will not be containing any value, so it will be left blank as it is. Thesis any, that means any arbitrary content which can be produced over the network that can be placed over this element, which is thesis. So these are the few element declarations which are used in the XML. Like we have seen the element declarations, similarly we can have the attribute declarations as well. So for attribute declaration, what is the keyword? The keyword, it is the @list. @list, after this the section number, and C data it is required, title, C data it is required. So it declares that there are two attributes for the element section. So first one, what I have to write over here in section, write the name of the element. This element will define, this element name will define that to which element the attribute will belong. So for the first one, declared number, this is the first attribute, and by writing hash required, that means the value is mandatory for it. Second attribute which is there, it is the title, again character data, and the value is mandatory for it. So this is the element name, this is the attribute name, what will be the attribute type, and the attribute default value. Let's see the attribute declarations in the DTD in detail. So this was the first one. First thing, it is required, hash required, that is it is required in each element instance. If I have written hash required, that means it is mandatory that the data must be visible. I cannot skip the data in such cases. Second one, implied. If I write implied, implied means that the data is optional. If I write the data or not, it is not, it will not affect the document. Like if I write over here title, C data, hash, implied. So if I write over here implied, what will happen? For this implied one, this title attribute, if I give the value, then it is well and good. If I do not give any value for this attribute, then also the DTD will not give any error, or it will actually parse the data as it is. So whatever the data description we require, that description will be done if I write over here implied. So that means it is not mandatory. Next one, fixed default value. If I want that the data must be of fixed value, like I want that the ISBN number to be a fixed value for any book. So for that I can give hash fixed default to the default value. If I want to change the value, then we can also change for it. Next one, it is the default. What is the default? Like if I do not write the attribute for any element, so what will happen in this case? Because each and every element will have an attribute and the attribute will have a value. If anything is missing, like the value is missing, the default value will be given to the attribute. If the attribute is missing, then the default attribute will be given to the element. So for those cases, the default is given. Like we are having C data, this is for the string. If I write A1, pipe, A2, pipe, A3, so that means all possible values which are there, we enumerate all those values. If I write over ID, ID means unique XML names to identify the element. ID ref, so what is that ID ref? It is the ID attribute. In this ID attribute, we are having some other element like intra document link is there, we can provide these values also over there. ID references, like all the references which are separated by the white spaces, that can be included into the ID ref. So this is the example of the attributes. In this attribute, we are having publication. As we have discussed, what is this publication? This is the element. in this publication, first attribute is type. So what can be the possible values for it? Type can be journal proceeding, it is required. If it is public ID, pub ID, so that is also required. If it is CID, ID reference, and it is required. Second one, we are having at least citation, the references ID ref implied and CID ID required. That means ID ref, it is optional, we can provide the value or not, and if I write over here CID, so that is required by it. Now, when I am going to declare it in XML, how it will be? Publications, since it was the name of the element, publications tag will be there. After publications tag, publication type, since this is a publication and this element, it is having the attribute type. So, type as an attribute will come over here. Type will be, suppose I written journal, so type is equal to journal, and then pub ID is required, so pub ID, publication ID, which I have given over here. Second one, author. For this author, we are having the name and the author tag is closed. Next, it is the text, because text author we do not have defined the attribute, so it will go with the default values. Then the cite, CID 12, then the text tag will be closed. Citation, this is the element over here for which we have defined the attribute. Citation, what is the attribute? For that we are having cite, CID, so this CID will come because it is required, and this CID, that means customer ID, value will be written over here and the references will be provided. CID, if I do not provide the reference, then also it will work, since here reference, it is implied. Implied means if I give the value or if I skip the value, it will not cause any problem in the DTD. Then the publication tag will be closed. This is the thing which will happen if I write the attribute declarations in the XML. So, IDs go there, citations, the tags will be closed. Next come linking DTD and the XML documents. Like I have written the DTD separately, I have written the XML separately. Now, how we are going to connect these DTDs and the XML files? For that, the document type declaration, what I will write, hashtag doc type, article, system, and from where the DTD can be fetched. So, doc type and the system, these both are the keywords. And this article, what is this article? This article, it is the root element, and this URI, it is the place where the DTD can be found. So, first way of linking XML and the DTD, they can be combined by two methods, internal and external. Let's see both one by one. First one, it is the internal DTD. In the internal DTD, XML version is equal to 1.0. After that, doc type article. In this, we have defined the complete DTD, like element article, what it will contain sub elements. Likewise, these sub elements will be having some values. We are skipping over here since we have discussed this in detail in the previous slides. Last one, index, and that will be having hash PC data. Now, this article, it is closed. So, we can have both ways, like we can have mix, we can have internal DTD which will completely override the external DTD. So, if I write over external, so doc type, name of the root element, system, name of the file, name of the DTD file, then entity and the content. In this way, I can have a mixed variations of these entities. Flaws, what are the flaws of DTD? The first and the foremost flaw, as we have been discussing DTD for a long time, the first thing is that we do not have the basic data types, like we do not have integers, doubles, strings. The data types are not defined in it. Second one, there is no structure over here. There is no definition. They are quite loose because the target is not specified for it. So, what comes to the rescue? Comes to the XML schema. So, what is schema? Schema, it is a XML application, and they are the simple types which are having string, integer, data type, duration, language, etc. All these things are over there. It always allows possible values for the elements and defining the derived from the existing types. They support complex type, and we can also have the constraints on the occurrence of the elements which was not in the DTD, and it can be used for the uniqueness and the foreign keys as well. This is a simplified XML schema example. How to define an element? Just write XML colon element. Then complex type sequence, again the element name, since these are the sub elements, so we will just write as it is without having the complex type. And element name, occurrence I can give, maximum occurrence we can give. To define the data type, what we should give? Type is equal to, and then we can write the data type. So XML parser, it is also there. What is the XML parser? It checks a well-formed syntax and it provides a capability to manipulate the XML data elements in the system. It can navigate through the XML documents, DOM, or the simple API for XML models. It extracts and query for the data elements. We can add, delete, or modify the data elements in it. We can read. So first model which is there, it is DOM model, document object model. It reads the whole document and then it builds the DOM tree. Second one, it is simple API for XML. It is a event based parsing method. So it reads the XML document, and for the calling back methods, it will contain certain events like elements, attributes, starting tag, ending tags. All these things are there to call this particular parser. So let's see both of these one by one. XML DOM, which is document object model, it is a standard model which is used to manipulate the read, modify the XML documents. And formally XML DOM, it is a programming interface and we can use it in our programs and manipulating the XML documents. It was designed by W3C and it is to be used by the programming languages and any other operating system it can use. This is the architecture. We are having an XML file. In this XML file, we are having the XML parser. File will be passed to the XML parser. It will convert the XML documents into a set of objects into the memory, and then these objects, they can be accessed and modified with the DOM interfaces. After that, it is fetched to the set of the objects DOM tree, which contains the information from the XML document, and then it is given to our program. So this is how this document object model works. So what it requires, it is a powerful document navigation part, and these documents, they require a lot of memory. For that, this is a major disadvantage for this document object model. So for this disadvantage, what we have the alternative? The alternative is simple API for XML model. So what will happen in it? It will fire the event based on the tags, like we are having all the document will not be passed. The passing will be done based on the tags which will be appearing over it. So already for the already passed elements, we do not have any way to access it, and there is no in-memory representation. So this is the advantage, but we cannot use the already passed data. So that is the disadvantage of simple API for XML. So this is how XML DOM will work. Bookstore, root element, book category is equal to cooking. So book, it is element, category, it is the attribute, and what is the value? Cooking. Then title, author, year, price, book tag is closed, similarly another thing. And so we are having basically three three nodes of a main root, which is the bookstore. So this is how this DOM tree will work. Root element, bookstore, parent child relationship is there for the element and book. For the book attribute, it is the category, attribute language, element title, element author. Similarly, element author, element year, element price, text is also there. So this is how this whole XML DOM tree will be looking like. So as we have seen, both parsing is very important in XML, because XML, it is used to describe the data. To describe the data, we need certain definitions. I need certain structure through which the data can be described. For that, the DTD comes to the scene. But the problem with DTD is that it do not define the data types. For that, schema comes. schema defines the data type, but also the structure needs to be parsed. For the parsing, we are having two types of parser, DOM and the simple API for XML. So this is how this DOM architecture works. In the DOM architecture, we are having a root element, which is anything it can be here, like over here it is the bookstore. In this root element, after that parent and child will be mentioned. Sub elements will be given over here, like I can easily find out, like book, what it is an element. Category, what value it is of an attribute. Lang, it is attribute. Title, it is element. Title and author, they are siblings, that means they are on the same platform. The node number, it is same for both of them, so they are the siblings. So we have to write all those things in the XML DOM tree. So this is the same example of the XML DOM, and this is the whole DOM tree which is corresponding to that particular example. Object model, as I have discussed, we are having nodes, type, name, values, first child, last child, nodes, siblings, parent, next. So DOM versus simple API for XML parsing. The simple and major difference between both of them is that for the simple API for XML, I cannot go back to the already parsed data, whereas in DOM it was possible, but in DOM again it was taking a lot of memory. But in simple API for XML, the memory is saved since the events are being fired at the tag event. So these are the limitations for the programmer's problem. It is not for the API, and cross referencing can always be there in the XML. Thank you.